So here's the solution to a coding challenge from Leetcode.com called remove duplicates from sorted array. And the problem goes as such. Given an integer array, num sorted in non-decreasing order, remove the duplicates in place such that each unique element only appears once. The relative order of the elements should be kept the same. Return k after replacing the final result in the first k slots of nums. And what k is the unique elements in the array. So you're gonna find the unique elements, that's k, whatever number, however many that is, and you're gonna replace those in the start of the nums array in place. The important part of this problem is do not allocate any extra space for another array. You must do this by modifying the input array in place with big O of 1 constant extra memory. So basically no extra memory. Like you can't use data structures, you can't use a set, you can't use a map, you can't use a temporary array. So before y'all jump on me in the comments, you cannot use extra space. You cannot use a data object, because I know somebody's going to jump in the comments and that's going to be the first thing they say. They're trying to make this problem harder by forcing you to do it without using extra memory, which is a fair ask to test your optimization skills of space complexity. Let's look at example 2. If you have 0 with all these 1s, with all these 2s, with all these 3s, you basically want to modify that array in place and just place the unique numbers at the start of the array, and it doesn't matter what you have at the end of the array as long as the first k elements of the array have been replaced with all the unique values of your original input array. So let's look at my first solution for this problem. My first thought was that since the problem doesn't allow you to use any extra memory, like no maps, no arrays, I could use the JavaScript splice function to basically remove the duplicates out of the array in place. And then since this array is in, the input array is in non-decreasing order, then I can just simply loop through, keep track of an index here, loop through. If the current value that I'm looping on equals the next value that I'm looping on, I know I have a duplicate or whatever. And so I can basically remove the current item out because I know I have a duplicate in the next item. Or if I don't, I can just go to the next spot in my array. But here I don't have to go to the next spot because I took it out of the array. And then I could just return the length, since the problem answer is asking for you to return the length of unique values that you have, the count of unique values that you have. So this works. It was successful, but it only beat 70 or 7% of time complexity of all other Leetcode submissions. But it's pretty good on memory because it doesn't use any extra space. So it made that requirement, but it's really bad, like 200 milliseconds. It's really not really good on time complexity. And the reason why is that you just look at the time complexity. I loop through the array at least one time. So that's big O of n. If the length of the array is called it n. And then when I use this splice function, that's the problem here. Using splice, worst case, to erase an item out of an array, you have to traverse the whole array because you have to take the item out and you have to move all the other items to their proper new indexes. Worst case, that's going to be another n. So this is actually n times however many times I call splice, because worst case, I have like a bunch of duplicates in the array. So that means this solution is big O of n squared time complexity, which is not very good. So let's see how I beat that. So my second solution, to use a second pointer or use a 2-pointer approach to update the array in place. So the new pointer I'm going to use, or the second pointer I'm going to use, is what I'm going to call an insert pointer. And I'm still going to loop the array as normal, but instead here, I'm going to have this pointer here, which is I, and then I'm going to have this separate insert pointer. And whenever I see that the current item, I'm going to start at 1 on my index. And whenever I see that the current item does not equal the last item, which means I changed from a same value to a unique, to a different value between them, then I'm simply going to take the unique value that's at the current spot that I'm in, and I'm going to update the array in place at the insert pointer with that value. Then I'm going to update the insert pointer. So that means I'm going to be updating the start of my array with the insert pointer and pushing my insert pointer along as I loop through the whole array. So by the time I get to the end, I've used my input insert pointer to update my array with unique values. Since it's in non-decreasing order, I know that whenever the value changes, I've gotten a new unique value. And at the end, I can just return the insert pointer because now it's equal to the count of unique values that I have. Hope that makes sense. Let's see how it performed. It beat 99.61% of all other Leetcode submissions with 56 milliseconds for time complexity. And it still beat 92.51% in memory. So it's way better than the last solution based on time complexity. Only thing I did that is tied to the size of my input, the length of my input, is I did one loop. All the rest of these operations are done in constant time. They're not tied to the size of my input. So that means the time complexity solution is big O of n, where n is the length of the input array, nums. And then space complexity, I didn't use any extra array. The problem said I couldn't, so I didn't use any extra array, map, or set. So the space complexity is big O of 1, constant space. So I hope this makes sense. Let me know if you can think of a way to do this better. Thanks for watching this video, and please like, subscribe, follow, all that good stuff. See you in the next one.